Hello everyone, I'm Amit Nainawat. I'm pre-sales engineer at Qt Company. During this session, I will talk about model-based HMI development using Qt framework. So today's agenda during this session is what is model-based HMI development. Then we will discuss why to use model-based HMI development and how model-based HMI development works. Is there some design tools which we can use for it? And the most interesting part, the demo of a model-based HMI designed with the Qt tools, and which is a vehicle dashboard. So first of all, what is the model-based HMI development? So it's a process to validate the whole system based on the mathematical models. So even if you don't have the hardware still manufactured, even in that case, you can connect your front-end HMI on a mathematical model, and based on this model, you can validate your HMI even before the hardware is manufactured. The model-based HMI development is to create the simulation modules and check whether your algorithm will work correctly before even the code is written for those algorithms. So it allows you to design your HMI in the advanced phase based on the mathematical models, and by doing that you can validate your HMI and later deploy it on a real hardware target. And why we should use a model-based HMI development. Traditionally, the HMI development is done by writing the specification on the PDF and text documents, and later these PDF and text document are interpreted by the designers and developer to create the HMI. It leads to some misunderstanding, misconception, and finally maybe the HMI itself, it need to wait a longer time to validate. So to overcome all this misuse and misunderstanding, we use the model-based HMI development. It allows to quickly iterate the design, as we already have a model of the hardware platform. We can validate the HMI really very fast and iterate it, maybe do some changes, modifications. Those modifications can be done in the advance of the phase before real hardware is available. As the model is running on the PC or on another simulated environment, so the one model can be targeted, can use as a target for the different devices. So the same model can target to the different devices. It also allows you to verify the specification of overall system design. By using the model-based HMI development, you already know in the advanced phase that your overall system design will work or not. It works in a spiral manner that you always get the feedback. You do first iteration, then you validate. There are some things missing, then you integrate the missing things in your HMI, and you do the iteration really fast. So it allows you to develop very fast the HMI. How does the model-based development work? So it works in the V-shape development model. So first you architect the model itself to create the mathematical behavior of your system itself. Then you have to design and simulate a hardware prototype. Once the simulation of the model is done, then you can start building your HMI software. And once the HMI software is ready, what we do is we do the in-loop testing, which is described here in the flash manner. So So the HMI software is being tested in loops, and then in this in loop, in this iteration, we we rectify the HMI software. We also rectify the model of the system itself. And finally, when whole model is validated, the system can the HMI can be deploy it on the target hardware device. So so the next question is, I want to use the model-based design. Now, which tools which I can use? So in the Qt ecosystem, we have uh, already have very good integration with the MATLAB Simulink models. So in the MATLAB Simulink model, you will already find Qt block set library, and by using the Qt block set library, you can easily communicate over the TCP to a Qt application. So for the designing the model itself, during my presentation, I will use MATLAB Simulink. And for the application side, you can use Qt Design Studio, which allows you to import the artwork from the Photoshop and from the Sketch. It allows you to create very fast UI, and later you can use the Qt Creator to compile those UI and deploy it on the target hardware. So during today's session, I will use Simulink for the models, and for the HMI development, I will use Qt Design Studio and Qt Creator. So just a quick word on my demos. The first demo is a car cluster running on the PC and on a IMX8 device, and this car cluster is connected to a Simulink model running on the PC. And this Simulink model, as I said, the MATLAB integrates the Qt block set, and this Qt block set is there, and it's ease the communication with the Qt application. The communication is done on the TCP. So the model can send signals to the application, and application can send signal back to the model. So it's a two-way communication on the TCP. So this will be my first demo. I will do I will run the front end HMI on the PC. Then I will, if there are some adjustment need to be done, we can do some adjustment on the PC, validate the HMI is running nicely on the PC, and later deploy the same HMI on a embedded device on IMX8. Validate the HMI by using the same model. This time the model will run on the PC, but the target application will run on the IMX8, and we can even validate the HMI on the target hardware. My second demo is going further. So instead of running the model on the PC, the model can even run directly inside the embedded target. That means Simlink model should able to run inside the target hardware, and for that Simlink provide tools, and by these tools, which is called embedded coder, you can convert your model in a C++ code, and this C and C++ code can then integrate directly inside in your project, and by that the model is integrated inside your application itself, and the application application can connect directly to this model. So the whole model is running inside the target application. So let's see my first demo.
In my first demo, a car cluster will be validated by using the Simulink car model. The initial step is to architect the model itself. The Simulink provides a easy to use Simulink library which integrates directly with the Qt application. And over the TCP, it can communicate. The model can communicate by the Qt application itself. And the Qt application, the car cluster application, car dashboard application, can also send the information via the TCP socket back to the Simlink module. All this is possible because Simlink already have a Qt block set library. Here in this model, the car is already modeled, and this model is using the Qt block set library of the Simulink for my for my input and for my output signals. Notice this model receives acceleration and deceleration value, and based on these two input values, it outputs speed, RPM, and gear values. All these input and output signals are using Qt block set library. So, and this Qt block set library will use TCP socket to connect with the car dashboard application. Without these two input signal, the car model do not trigger the output signal. So we have to provide the acceleration signal to the car model to have speed, RPM, and gear as output signal. Let's run this simulation. On the another hand side, the target application, the car dashboard application, is designed and developed by the Qt Design Studio. More information on this, please see Qt Designer Developer Workflow, where artwork from the Photoshop or from the sketch is imported in the Qt Design Studio to create a car cluster. I have taken Qt Designer Developer Workflow project, and here in this project I will add the Simulink class, which is done in the main.cpp. So if I open my main.cpp, you can see that the Simulink library is initialized by this class Simulink plugin, and this class is initializing the main QML component. Also, it listens to the local host TCP socket. It listens to the local host because currently I'm just running the model on the local PC. This Simulink class sends and receives different signals, and those signals are received inside the QML directly. The signal, they share the same name in the Simulink module and the Qt application, and that how it makes the binding between them. Let me show you that. So here the output signals are called speed prop, RPM prop, and gear property. And just because it's called the same inside the model itself, they share the same signal. Same for the input parameter. Signal acceleration, signal deceleration shares the same signal name, and that how there is the binding done between the between the Qt application and the Simulink model itself. Now let me run the dashboard application first on the desktop, my on my Windows PC. . So I will run it on my Windows PC. Remember, on the another hand side, I have already started the model, the car model. Here, my application is running on my Windows PC. Now both Qt application and the car model is connected via the local TCP socket. Notice on the left top side, this slider gives the value of the acceleration and the value of the brake to the Simlink model. And based on these two input, the model outputs speed value, the RPM value, and the gear value. Let's let's start the simulation and check whether my HMI is working as I was expecting. So I accelerate the car. So my car is now running, and it's time to now iterate on my dashboard application. As I have the car model which is already running, I could iterate my dashboard application quickly, do the required modification in my HMI, validate it validate it between the different teams, and finally creates a nice looking dashboard HMI. Once when everybody is happy with the dashboard HMI, when the RPM is working fine, when the gears are working fine, and the whole look and feel of the HMI is working as expected. Now the HMI can be tested on an embedded device, which will go directly inside a real car. Here, here I have a IMX8 device. Just few words on this IMX8 device. This device is running a Linux called boot2qt. This Linux is provided by the Qt company. My IMX8 device is sitting on this IP address written here also, and I have already configured my Qt creator to cross compile my dashboard application for my IMX8 embedded system. So I let me just compile and deploy my application. So my application is being compiled. Before I have to do one more modification in my application. So I go to my main.cpp. So this time I will not listen to the local host. The Simulink model will run on the PC, and my embedded device it is sitting on a different network. So I will listen to all ports. Okay, and I have to restart my model, and this time I have to give the IP address of my IMX8. So let's check again the IP address of the IMX8, and I'm going to change this IP address here. So 169.254.198.82. Okay, okay. So now my model will be communicating with this IP address, and this is the IP address of my IMX8. Again, I run my model. On the another hand side, You might know that by the Qt creator, you can cross compile your application for different target devices, and this is done by set of rules, and these rules are called these rules are all stored in a kit. So I can compile my dashboard car application to the IMX8. So let me compile and deploy my application. So now my application is running on the IMX8. Again, it has the same look and feel as it was designed on the Windows PC. But now we are going to validate this HMI from the model which is already running. So let me accelerate the car again. So when I accelerate my car, you can see that the Simulink model is sending me the RPM, the speed value, and the gear value. So this is very nice, and thanks to the simulation module, I can again iterate on my dashboard application, make the changes is required, again check my application against the specification. So it enables me, the model-based HMI development enables me to develop my application without even needing a real car, without even connecting to the real backend of a car. Now going further, modeling of the system can also be done directly inside the target device. So currently here the model is running on the PC, and which is connected to the embedded device, like here. So it is connected with the embedded device like here. But the model itself can run directly inside the target device, and this is my second example. So in this second example, the model and the application, both of them will run inside the NXP RT1050 MCU. So for this example, I have another simple model which is here, and this model outputs only one value, which is the speed value. Again, this is a simple module, and this simple module can be used to generate the C code of this model itself. And the generation of the C code of this model is done by embedded C coder of the Simulink. Once this C code is generated for this model, that C code can be directly integrated in a target application. That means this simulation is no more done on the PC. The simulation can directly run on the target hardware. So here in another example, the cluster mini. This is the generated code for that simple model, and this generated code is integrated directly inside a mini cluster MCU project. So this mini cluster MC project can now be compiled across various MCB, across various MCU. I have I have the NXP RT1050 MCU running here. This is running a thermostat application which is leveraged the Qt for MCU project. The Qt for MCU enables you to develop uh, touch-based application, and it also enables you to develop the smartphone-like applications. So now let's just compile our application for the RT1050. So I'm compiling my application, and my application will be returned to the MCU. Okay, it's here. I can see that the LED is blinking on the downside. That means application is being written by the Qt creator. So the Qt creator is the IDE which is even used for developing on the MCU. You can write your application directly by the Qt creator. So application is written. The model of the car is running. That's why you can see the needle of the application is moving. So here both the model of the car and the application are integrated inside the device. Again, I can check my design, play with the different parameter, adjust my HMI design without even needing a real backend of a car. So model-based HMI design hence quickly iterate on the design, validate the HMI on the different target hardwares like we done on the desktop, on the IMX8, on the MCU. And once you are happy with your HMI, you can go in the production very fast. So model based HMI design enables you to verify the specification of or all system designed in a shared sim- simulated environment on the various target.
Thank you very much for participating during this session. It was a pleasure showing you these two demo. I hope it will give you some ideas to work uh, with the model-based HMI development. Bye for now.